Look up at the night sky. What do you see? Stars, planets, maybe the moon if you're lucky. But there's so much more going on up there than meets the eye. The universe is stranger than we ever imagined. It's full of phenomena that seem impossible, discoveries that challenge everything we think we know, and mysteries that make us question our place in the cosmos. What you're about to learn isn't science fiction. These are real discoveries, backed by decades of research and observation. Some will make you smile, others will blow your mind, but all of them reveal just how extraordinary our universe really is. So, without further ado, let us get to our first incredible space fact. Right now, as you watch this video, something incredible is happening. Tiny pieces of ancient comets are falling through Earth's atmosphere and landing all around you. Some might even be settling in your hair. It's happening right now, and it's been happening every single day for billions of years. Every day, about 14 tons of material from space falls to Earth. Think about that for a moment. While some of this arrives as spectacular meteors lighting up the night sky, most of it comes down so gently and quietly that we never notice it. This invisible rain of cosmic material adds up to around 5,200 tons every year, steadily adding bits of space to our planet. But where does all this stuff come from? Most of it, about 80%, comes from a special family of comets that orbit relatively close to us. They're called Jupiter family comets because their orbits are controlled by Jupiter's gravity, and they take less than 20 years to go around the Sun. These comets are constantly shedding tiny pieces of themselves as they travel through space. When we say tiny, we mean really tiny. Most of these particles are no bigger than a few tenths of a millimeter across. That's smaller than a grain of sand. They're so small that when they hit our atmosphere, they don't burn up in a flash like bigger meteors do. Instead, they float down gently through the air, eventually settling on Earth's surface, and yes, sometimes in your hair. These particles aren't just ordinary dust. They're ancient pieces of our solar system, formed around 4.6 billion years ago. Each speck contains materials that were present when Earth and the other planets were just starting to form. When you brush these particles out of your hair, you're literally touching pieces of the early solar system. But it gets even more interesting. These particles create something called the zodiacal cloud, a huge disk of dust in the inner solar system. Jupiter family comets contribute more than 90% of the mid-infrared emission from this cloud. What does that mean? It means these comets are constantly filling our neighborhood of space with a fine mist of cosmic debris. Scientists have actually figured out exactly how much of this space dust hits Earth's atmosphere. About 85% of all the cosmic material entering our atmosphere comes from these Jupiter family comets. The rest comes from other sources like asteroids and more distant comets. That means most of the space dust you might find in your hair originally came from comets that are practically our next-door neighbors in cosmic terms. The reason we can't see this cosmic rain with our naked eyes isn't just because the particles are small. It's because they enter our atmosphere very differently from the meteors we can see. When larger objects hit our atmosphere, they create those bright streaks we call shooting stars. They're actually burning up from the friction of hitting our atmosphere at incredibly high speeds. But these dust particles are so small and light that they don't create enough friction to burn. They simply drift down through the layers of our atmosphere until they reach the ground. Scientists use specialized instruments to detect and study these particles. They've found them everywhere from Antarctic ice to the tops of skyscrapers. Every time you step outside, you're walking through a gentle rain of cosmic material that connects you directly to the depths of space. Think about that the next time you wash your hair. Some of those particles going down the drain might have spent millions of years traveling through space before ending their journey in your shower. They might have been part of a comet that formed when dinosaurs roamed the Earth, or even earlier. Each speck is a tiny time capsule from the history of our solar system. This constant addition of material from space isn't just a cosmic curiosity. It's part of a process that's been happening since Earth formed. Our planet has been collecting space dust for billions of years, gradually growing very slightly larger over time. While 14 tons per day might sound like a lot, it's such a tiny amount compared to the size of Earth that it would take millions of years to notice any difference in our planet's mass. The next time someone tells you to get your head out of the clouds, remember this. Those same clouds might be carrying tiny pieces of comets that are older than human civilization. Space isn't just something far away that we can only see through telescopes. Little pieces of it are falling around us all the time, settling in our hair, on our clothes, and in our backyards. We're constantly in touch with the cosmos, whether we realize it or not. Want to get rich? Well, you might want to look up at the stars. That gold ring on your finger, that silver necklace in your jewelry box, even that platinum credit card in your wallet. Would you believe that all of these precious metals were created in one of the most violent events in the universe? When stars die and collide, they create nature's most expensive fireworks show, forging gold, silver, and platinum in the process. Let's talk about how this cosmic alchemy works. It starts with neutron stars, which are already pretty extreme objects. These are what's left over after some stars explode as supernovas. But as incredible as supernovas are, they're just the opening act. The real magic happens when two neutron stars collide. When these stellar remnants crash into each other, they create something more powerful than any explosion we can imagine. The energy released in these collisions is far greater than a supernova, and the temperatures and pressures are so extreme that they can do something remarkable. They can create some of the heaviest elements in the universe, including the precious metals we value so much. Scientists call this process our process nucleosynthesis. Think of it as nature's pressure cooker, cranked up to temperatures and pressures that make the center of our sun look chilly. During these collisions, atomic nuclei are forced to absorb neutrons so quickly that they bulk up, creating heavier and heavier elements. This is how we get elements like silver, with its atomic number of 47, platinum at 78, gold at 79, and even uranium at 92. And we're not talking about small amounts here. A single neutron star collision can create an amount of gold several times the mass of Earth. Yes, you heard that right. One cosmic fender bender can forge more gold than our entire planet's mass. Imagine all the gold ever mined throughout human history. Now multiply that many, many times over. That's how much precious metal these collisions can produce in just moments. We actually witnessed one of these cosmic forges in action back in 2017. Using special observatories called LIGO and Virgo, scientists detected gravitational waves from two neutron stars colliding 130 million light-years away. When they studied the aftermath of this collision, they found clear evidence of heavy metals being created in the cosmic debris. Recent studies have shown that these neutron star mergers are incredibly efficient at producing heavy elements. In fact, over the past 2.5 billion years, they've been 2 to 100 times better at creating heavy elements than collisions between neutron stars and black holes. They're like cosmic factories, churning out precious metals with incredible efficiency. But here's something even more mind-blowing. About half of all elements heavier than iron in the universe were created by these collisions. That means the atoms making up your gold wedding ring might have been forged in a neutron star collision billions of years ago, long before our solar system even existed. These atoms traveled through space for billions of years before eventually becoming part of Earth, being mined, refined, and shaped into jewelry. While neutron star mergers are the main source of these precious metals, they're not the only source. Other exotic events like collapsars, which are the collapse of massive stars, and special types of supernovas also play a role in creating heavy elements. It's like the universe has multiple recipes for cooking up gold and silver. But neutron star collisions are the master chefs. Think about this the next time you're admiring something made of gold or silver. Those atoms were created in conditions so extreme that we can barely comprehend them. Temperatures hotter than anything we could create on Earth, pressures that would make the center of our planet seem like a gentle squeeze, and explosions so powerful they send ripples through the fabric of space and time itself. The jewelry store won't tell you this, but every piece of gold they sell was forged in the death throes of stars. Every silver ring was created in an explosion that would make our most powerful nuclear weapons look like firecrackers. Every platinum necklace contains atoms that were born in conditions more extreme than anything we could ever recreate on Earth. So yes, precious metals are valuable, but maybe not just for the reasons we usually think. Their true value might lie not in their rarity or their beauty, but in their origin story. They're more than just metals. They're pieces of cosmic history, created in events so powerful they shake the universe itself. The next time someone asks why gold is so expensive, you can tell them it's because each atom was handcrafted in a collision between dead stars. Get ready for something that might break your brain a little bit. On Mercury, a day is twice as long as a year. The closest planet to our Sun somehow manages to have days that last twice as long as its years. Let's figure out how this bizarre situation works. First, let's talk about what we mean when we say a year. A year is simply how long it takes a planet to go around the Sun once. Mercury races around the Sun pretty quickly. While Earth takes 365 days to complete one orbit, Mercury only needs 88 Earth days. So a year on Mercury is 88 Earth days long. But this is where things start to get weird. You might think that a day is just how long it takes a planet to spin once on its axis. And you'd be partly right. This is what scientists call a sidereal day. And on Mercury, one complete rotation takes 59 Earth days. That's already pretty strange. Mercury spins very slowly compared to Earth. But there's another way to measure a day, and this is where things get really interesting. When we experience a day here on Earth, what we're really noticing is how long it takes for the Sun to appear to move across our sky and return to the same position. This is called a solar day, and it's what most of us think of when we think about a day. On Mercury, because of its slow rotation and quick orbit around the Sun, a solar day takes 176 Earth days. That means if you were standing on Mercury's surface, you would have to wait 176 Earth days between one sunrise and the next. And here's the mind-bending part. During that single Mercury day, the planet would have gone around the sun not once, but twice. In the time it takes Mercury to experience just one day-night cycle, it completes 2 whole years. By the time the sun rises again in the same spot, Mercury has orbited the sun 2 complete times. It's like running around a racetrack twice, while only turning to face each direction once. This happens because of 2 things: Mercury's very slow rotation and its speedy orbit around the sun. Imagine you're on a merry-go-round, but you're turning very slowly in the opposite direction from how the merry-go-round is spinning. That's kind of what's happening on Mercury. The planet is spinning on its axis very slowly in one direction, while zipping around the sun very quickly in another. The effects of this would be pretty dramatic if you were actually on Mercury's surface. You'd experience one brutally long day that lasts about 176 Earth days. During this time, you'd see the sun rise, creep very slowly across the sky, set and then stay set for what would feel like an eternity before finally rising again. And we haven't even talked about the temperature swings yet. Because Mercury is so close to the sun and has such long days, the temperature differences between day and night are extreme. During the long day, temperatures can reach 800 degrees Fahrenheit, hot enough to melt lead. During the long night, they can plunge to minus 290 degrees Fahrenheit, cold enough to freeze carbon dioxide solid. Imagine trying to survive on Mercury. If you were a space explorer stranded there, you'd face some serious challenges. Your solar panels would be useless for half of each Mercury day, which, remember, is longer than a Mercury year. You'd have to find a way to survive both scorching heat and freezing cold. Any kind of farming would be impossible because of these extreme temperature swings. This weird relationship between Mercury's day and year teaches us something important about how our solar system works. We often take for granted that days and years work the way they do on Earth, but Mercury shows us that these relationships can be very different on other worlds. What we consider normal is just one possibility among many. Even after all these years of studying our solar system, Mercury continues to fascinate scientists. It's the smallest planet, the closest to the sun, and the one with this bizarre day-year relationship that seems to defy common sense. Yet it's all perfectly explainable by the basic laws of physics and orbital mechanics. So the next time someone tells you they're having a long day, remind them it could be worse. They could be on Mercury, where a single day lasts longer than 2 whole years. It's just another reminder that our universe is full of surprises, even in our own cosmic backyard. Let's talk about the most extreme objects you could ever imagine. Forget black holes for a moment. We're going to discuss something almost as wild: neutron stars. And what you're about to learn about their density will absolutely blow your mind. Picture this. Take a single teaspoon, the kind you have in your kitchen drawer right now. Now imagine that spoon filled with material from a neutron star. That one tiny spoonful would weigh more than every human being on Earth combined. Yes, you heard that right. A single teaspoon of neutron star material weighs more than 8 billion people. But it gets even more incredible. If you wanted to create something as dense as a neutron star, you would need to take every single person on Earth and squeeze them down into a space the size of a sugar cube. That's the kind of density we're talking about. It's so extreme that our brains can barely process it. Let's put some numbers to this. A typical neutron star has about 1.4 times the mass of our Sun. But instead of being spread out like our Sun, all that mass is crushed down into a ball only 10 kilometers across. That's smaller than most cities. Imagine taking something heavier than our Sun and squeezing it down to the size of a city. The density is astronomical, about 3.7 times 10 to the 17th kilograms per cubic meter. If that number sounds meaningless, it should. It's so large that we don't have anything in our everyday experience to compare it to. The closest comparison we can make is to the density of an atomic nucleus. That's right. A neutron star is so dense that it's essentially one giant atomic nucleus, the size of a city. It's 14 orders of magnitude denser than the core of Earth. To understand what that means, imagine the densest material you've ever encountered. Then multiply that density by a number so large we don't even have a word for it. This incredible density creates some pretty wild effects. The gravity at the surface of a neutron star is so intense that it bends the fabric of space and time itself. If you were somehow standing on a neutron star, which you absolutely couldn't, you would need to be moving at 40% the speed of light just to escape its gravitational pull. For comparison, to escape Earth's gravity, you only need to be moving at 0.00001 times the speed of light. But how do neutron stars get this dense? It starts with the death of a massive star. When these stars run out of fuel, they explode in a supernova. The outer layers blast away into space, but the core collapses in on itself. The pressure is so intense that it crushes protons and electrons together, forcing them to combine into neutrons, hence the name, neutron star. The pressure doesn't just stop there. It keeps crushing these neutrons together until they're packed as tightly as the laws of physics will allow. Any denser, and the star would collapse into a black hole. Neutron stars are literally balancing on the edge between normal matter and complete gravitational collapse. Think about this. Every single sugar cube-sized chunk of a neutron star contains more mass than all of Mount Everest. If you could somehow scoop out a teaspoon of neutron star material, which you couldn't, because it would immediately explode without the crushing gravity holding it together. That spoon would weigh about 1 billion tons. That's more than all the buildings in New York City combined. The gravity is so strong that if you dropped a marshmallow onto a neutron star from a height of 1 meter, it would hit the surface with more energy than 1,000 nuclear bombs. The surface gravity is about 200 billion times stronger than what we feel on Earth. A simple jump on a neutron star would release enough energy to destroy an entire planet. These stars are the ultimate example of just how extreme the universe can get. They're what happens when you take the mass of a star and crush it down as far as it will possibly go without turning it into a black hole. They're nature's way of showing us what matter looks like when you push it to its absolute limit. And here's something to really bend your mind. Despite being so incredibly dense, neutron stars are actually mostly empty space. The neutrons themselves are still made up of quarks with space between them. It's just that the gravitational pressure is so intense that this is as close as they can possibly be pushed together while still remaining matter as we understand it. So the next time you're stirring sugar into your coffee, remember, that teaspoon you're holding could, if filled with neutron star material, weigh more than every person on Earth combined. It's a reminder that in our universe, reality is often far more incredible than anything we could imagine. Stars are cool, literally. Now, before you start arguing that stars are actually blazing hot balls of fire, let me introduce you to some of the most fascinating objects in our galaxy. Stars so cool you could theoretically touch them without burning your hand. While most stars would vaporize you instantly, these cosmic oddities are more like lukewarm bath water. We are talking about Y-type brown dwarfs, the cosmic underachievers of the stellar world. Scientists often call them failed stars, which might sound a bit harsh, but it is actually a pretty good description. These objects form like stars, but never quite manage to achieve their full potential. They are the stars that could not. Let's talk about what makes a normal star burn. Our Sun, like all proper stars, is powered by nuclear fusion in its core. Deep inside, hydrogen atoms slam together with enough force to create helium, releasing enormous amounts of energy in the process. This is what makes stars hot enough to cook anything that comes near them. But brown dwarfs, particularly these Y-type ones, never get hot enough to start this nuclear fusion process. They are simply too small. Without fusion going on in their cores, they just slowly cool down over time, like a cup of coffee left on your desk. The result? Some of these objects have surface temperatures that would feel only moderately warm to the touch. Take WISE 1828 plus 2650, one of the coldest Y dwarfs we have discovered. This cosmic lightweight has a temperature of around 27 degrees Celsius, about 80 degrees Fahrenheit. That is roughly room temperature on a warm day. Your morning cup of coffee is actually hotter than this star. Even more remarkable is WISE 0855, another Y dwarf that is actually colder than your body. This cosmic snowball maintains a temperature between -48 and -13 degrees Celsius. That means it is not just cool enough to touch, it is literally colder than you are. Your body heat would actually warm up the surface of this star. Now, this might seem to break everything we think we know about stars, but it actually tells us something important about the universe. The line between stars and planets is not as clear as we once thought. These Y dwarfs sit right in the middle, not quite stars, but not quite planets either. They are cosmic in-betweeners. The discovery of these ultra-cool stars has forced astronomers to rethink what we mean when we say something is a star. They are technically classified as stars because of how they form, but they have more in common with giant planets like Jupiter than they do with stars like our Sun. They are massive enough to generate their own heat through gravitational contraction, but not massive enough to trigger the nuclear fusion that powers regular stars. Finding these cosmic coolies is not easy. Because they are so cool, they do not give off much light. Most of what they do emit is in the infrared part of the spectrum, making them invisible to our eyes. It is like trying to find a black cat in a dark room. We need special infrared telescopes just to know they are there. This is why we did not even know these objects existed until relatively recently. We needed to launch sophisticated space telescopes like WISE, the Wide Field Infrared Survey Explorer, to detect them. Even then, finding them is like looking for a candle flame in the middle of a fireworks show. The hotter, brighter stars tend to steal the spotlight. But these cosmic underachievers are actually incredibly common in our galaxy. Astronomers estimate that there might be as many brown dwarfs as there are regular stars. They are just harder to spot because they are so dim. It is like discovering that half the population of a city has been invisible to you all along. The existence of these cool stars challenges our understanding of what is possible in the universe. We used to think that all stars were necessarily hot, that being hot was part of what made a star a star. But nature, as usual, turns out to be more complicated and more interesting than we imagined. These failed stars might not have achieved their fusion-burning dreams, but they have taught us something valuable about the diversity of objects in our galaxy. They remind us that the universe does not always fit into our neat categories. Sometimes it exists in the in-between spaces, in the gray areas between what we think of as a star and what we think of as a planet. So the next time someone tells you that all stars are hot, you can tell them about these cosmic coolies. Tell them about the stars you could touch without burning your hand, about the stars colder than your own body temperature. Tell them about the failed stars that succeeded in teaching us something new about our universe. Just do not try to actually touch one. Even if you could survive the trip through space to reach one, these brown dwarfs are still massive objects with crushing gravity. But it is fun to think about. Somewhere out there in space, there are stars cooler than your morning coffee. Think the oceans on Earth are impressive? Get ready, because what you're about to learn about water in space will make our oceans look like a drop in the cosmic bucket. Let's start close to home, in our own solar system. Jupiter, that giant planet with its swirling storms, is hiding something incredible. 3 of its moons, Europa, Ganymede, and Callisto, are harboring a secret beneath their icy surfaces. Vast oceans of liquid water. These aren't just small seas. We're talking about oceans that would make Earth's look modest by comparison. Take Europa, for example. This moon, despite being smaller than our own moon, has an underground ocean that contains twice as much water as all of Earth's oceans combined. That's right, a moon that could fit inside Earth multiple times somehow has twice the water. But wait, it gets better. Ganymede, Jupiter's largest moon and the biggest moon in our entire solar system, has even more water hidden beneath its surface. Scientists have discovered that its underground ocean contains more water than all of Earth's oceans put together. Imagine all the water on Earth, then add even more. That's what's lurking beneath the surface of just one moon orbiting Jupiter. But Jupiter isn't hoarding all the water moons for itself. Saturn has its own water worlds. 2 of its moons, Enceladus and Titan, also have underwater seas. Enceladus is particularly spectacular because it actually shoots its ocean water into space through cracks in its icy surface, creating enormous geysers that feed Saturn's rings. But here's where things get truly mind-blowing. All the water we've talked about so far, all of Earth's oceans, all the water on Jupiter's moons, all of Saturn's watery moons, it's nothing compared to what astronomers have found in deep space. 12 billion light-years away, there's something that defies imagination. Around a supermassive black hole, scientists have discovered a cloud of water vapor so vast it almost breaks our ability to comprehend it. This cosmic reservoir contains 140 trillion times more water than all of Earth's oceans combined. Let that sink in for a moment. Not just a trillion times more water, 140 trillion times more water. If you tried to fill that space with Earth's oceans, you would need to copy and paste every drop of water on our planet 140 trillion times. And remember, this isn't liquid water like we have here on Earth. This is water vapor surrounding a black hole that's 20 billion times more massive than our Sun. What makes this discovery even more incredible is how far away it is. When we look at this massive cloud of water, we're actually looking 12 billion years into the past. That's because it's taken 12 billion years for the light from this region to reach our telescopes. This means that vast amounts of water existed in the universe when it was very young, almost at the beginning of everything. This discovery tells us something profound about water in the cosmos. We used to think that water was special, that Earth was unique because of our oceans. But now we know that water exists everywhere in the universe, from the moons in our cosmic backyard to the most distant regions we can observe. The water we've found in space exists in all sorts of forms. On Jupiter's and Saturn's moons, it's liquid water hidden beneath sheets of ice, kept warm by the gravitational forces of their parent planets. In the vast cloud 12 billion light-years away, its water vapor spread across an unimaginably large region of space, surrounding a black hole so massive it could swallow our entire solar system many times over. Think about this. The water molecules in your glass might be billions of years old, formed in the earliest days of the universe. Water, this simple combination of hydrogen and oxygen, has been around almost as long as the universe itself. It's not just an Earth thing, it's a universe thing, and we're still finding more. Every time we look deeper into space, every time we examine another moon or planet more closely, we seem to find water. It's in the polar ice caps of Mars, it's in the rings of Saturn, it's in distant clouds between the stars, and it's floating in unimaginable quantities around distant black holes. So the next time you take a drink of water, remember, you're tasting something that exists throughout the cosmos, from the moons of Jupiter to clouds 12 billion light-years away. Water, far from being unique to Earth, turns out to be one of the universe's most common and enduring features. Ever felt lonely looking up at the stars? Well, what you're about to learn might change that feeling forever. Our galaxy is absolutely teeming with planets that could be a lot like Earth. And when we say a lot, we mean billions of them. Let's put some numbers to this discovery. In 2019, astronomers made an incredible announcement. By combining data from NASA's Kepler Space Telescope and the European Space Agency's Gaia mission, they found something astonishing. For every 6 stars you see in the night sky, one of them might have an Earth-sized planet orbiting in just the right spot for liquid water to exist on its surface. Now, our Milky Way galaxy contains about 400 billion stars. That's already a mind-boggling number. But here's where it gets really interesting. About 7% of those stars are similar to our Sun. That might sound like a small percentage, but remember how big our starting number was. 7% of 400 billion is still an enormous number of Sun-like stars. So let's do the math together. If 1 in every 5 Sun-like stars has an Earth-like planet, and we have billions of Sun-like stars in our galaxy, that means we could have as many as 6 billion Earth-like planets in the Milky Way alone. 6 billion potential Earths. But what do we mean when we say Earth-like? Scientists aren't necessarily looking for an exact copy of our planet. They're looking for rocky planets that are roughly the same size as Earth, orbiting their stars at just the right distance. This distance is called the habitable zone, or, as some scientists like to call it, the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on the surface. The Kepler Space Telescope, which provided much of this data, was specifically designed to look for these kinds of planets. Think of it as a planet hunter staring at thousands of stars, watching for tiny dips in their brightness that might indicate a planet passing in front of them. Thanks to Kepler, We now know that planets aren't rare at all. They're everywhere. Scientists are beginning to realize that what we consider habitable might be too narrow. We're finding that life might be able to exist in environments we once thought were too extreme. This means the number of potentially life-supporting planets could be even higher than 6 billion. Some scientists estimate there could be anywhere from 300 million to 6 billion Earth-like worlds in our galaxy. Even if we take the lowest estimate, that's still 300 million planets that could potentially support life as we know it. 300 million chances for something extraordinary to have developed on another world. And remember, we're just talking about our galaxy. There are hundreds of billions of galaxies in the observable universe. If we extrapolate these numbers to the entire universe, the number of potentially habitable planets becomes almost impossible to comprehend. These discoveries are changing how we think about our place in the cosmos. Just a few decades ago, we weren't even sure if other stars had planets. Now we know that planets are the rule, not the exception. We've gone from wondering if we'd ever find another Earth to realizing we might be surrounded by billions of them. The implications are staggering. Each of these planets has been around for billions of years. Each one is a world unto itself, with its own geography, its own climate, its own potential for harboring life. Some might have oceans like ours. Others might have completely different environments that could still support life in forms we haven't even imagined. What makes this even more exciting is that we're still in the early days of our search. The 6 billion Earth-like planets we're talking about are just the ones we can estimate based on our current understanding. As our technology improves, as we launch more advanced telescopes and develop better ways of studying distant planets, we might find even more potentially habitable worlds. Every star you see in the night sky could be someone else's sun. And while not every star will have an Earth-like planet, knowing that billions of them might mean the universe is a far more interesting place than we ever imagined. We're not alone in the sense that we share this galaxy with countless other worlds that, at least in terms of their basic properties, are a lot like our home. So the next time you look up at the night sky, remember this. In our galaxy alone, there could be 6 billion other Earths out there. 6 billion chances for something remarkable to have happened. 6 billion possibilities waiting to be discovered. Here's a mind-bending comparison that will make you think differently about our galaxy. There are probably more stars in the Milky Way than the total number of human beings who have ever been born. Every person who has ever walked the earth, every ancestor you've ever had, every historical figure you've ever read about, and everyone alive today. Add them all up, and the stars in our galaxy still outnumber them. Let's break this down. When scientists try to count the stars in our galaxy, they come up with some staggering numbers. Some say 100 billion stars. Others estimate 300 billion. Some even suggest there might be as many as 500 billion stars in the Milky Way. That's quite a range, isn't it? But why can't astronomers agree on an exact number? The answer lies in just how challenging it is to count stars in our galaxy. Imagine trying to count all the fish in the ocean while floating in a boat. You can see the fish near the surface, but what about all the ones in the deep? It's a similar problem with stars. We can see plenty of stars from Earth, but most of our galaxy is actually hidden from view. Think about what our galaxy looks like in the night sky. A beautiful band of light we call the Milky Way is only a tiny fraction of what's actually out there. Vast clouds of dust and gas block our view of many stars. Even the stars we can see are often so far away and so close together that our most powerful telescopes can't separate them into individual points of light. So astronomers have to make their best estimates based on what they can observe, combined with their understanding of how galaxies work. They look at the parts of the galaxy they can see clearly, figure out how many stars are in those regions, and then use that information to estimate how many stars might be in the parts they can't see as well. It's like estimating how many jelly beans are in a jar, but on a cosmic scale. Now, let's look at the other side of this comparison: the total number of humans who have ever lived. You might think this number would be even harder to figure out than counting stars. After all, how could we possibly know how many people lived thousands of years ago? But surprisingly, anthropologists and demographers are actually more confident about their human population estimates than astronomers are about their star counts. The most recent calculations suggest that about 117 billion human beings have been born since our species first appeared. This number comes from careful study of historical records, archaeological evidence, and our understanding of population growth patterns throughout human history. While it's not an exact count, scientists are fairly confident in this estimate. So let's put these numbers side by side. On one hand, we have somewhere between 100 billion and 500 billion stars. On the other hand, we have about 117 billion humans who have ever lived. Even if we take the lowest estimate for the number of stars, we're still looking at about the same number as all humans who have ever existed. And if we take the higher estimates, there could be 4 or 5 times as many stars as humans. Think about what that means. Every time you look up at the night sky, you're seeing just a tiny fraction of a collection of stars so vast that it outnumbers every member of our species who has ever drawn breath. Each of those stars is a sun, many of them larger than our own, and many of them with their own families of planets. What makes this comparison even more fascinating is that while the number of humans who have ever lived continues to grow, the number of stars in our galaxy stays relatively stable. Yes, new stars are born and old ones die, but this happens over millions or billions of years. Meanwhile, Earth's current population of 8 billion people is about 7% of all humans who have ever lived. This comparison gives us a new way to appreciate just how enormous our galaxy is. We often think of the human population as huge, especially considering how much of an impact we've had on Earth. But compared to the number of stars in just our galaxy, all of humanity throughout all of history would still be outnumbered. And remember, we're just talking about our galaxy. The Milky Way is just one of hundreds of billions of galaxies in the observable universe. So while we might be outnumbered by the stars in our galaxy, the total number of stars in the universe is beyond anything we can truly comprehend. So the next time you look up at the night sky, remember this: for every person who has ever lived, there's at least one star up there, and probably several more. Each one shining, each one a sun in its own right, each one a reminder of just how vast and amazing our cosmic home really is. Saturn's rings are one of the most beautiful sights in our solar system. But there's something about them that most people don't realize, something that makes them even more incredible than they appear. These magnificent rings, which look so solid and substantial through a telescope, are actually more like a sheet of paper wrapped around a basketball. Let's talk about just how big Saturn's rings are. They stretch out to a distance of 140,000 kilometers from Saturn's equator. That's about 1/3 of the distance from Earth to the Moon. Pretty impressive, right? But here's where things get really interesting. Despite being wide enough to wrap around Earth more than 3 times, these rings are only a few hundred meters thick at most. If you could somehow stack 100 Empire State Buildings on top of each other, that stack would still be thicker than Saturn's rings. Yet these rings stretch out for a distance that would take a commercial airplane more than a week to fly across, if it could fly in space. Here's another way to think about it. Take a Blu-ray disc. It's about 120 millimeters wide and 1.2 millimeters thick. Now, to match the scale of Saturn's rings, you'd need to make that disc about 1 kilometer wide while keeping it the same thickness. Imagine a disc as wide as 10 football fields, but no thicker than the one sitting in your video player right now. The numbers get even more mind-bending. Using the most generous estimates of the ring's thickness at about 1 kilometer, they're still 250,000 times wider than they are thick. Some parts are even thinner than that. If you made a scale model of Saturn 1 meter wide, its rings would be 10,000 times thinner than a razor blade. But these rings aren't just impossibly thin. They're also not solid. They're made up of trillions upon trillions of individual pieces, mostly ice with a bit of rock mixed in. These pieces range in size from tiny particles as fine as dust to chunks as big as houses. All of these pieces are orbiting Saturn, moving in an elaborate cosmic dance that creates the illusion of solid rings when viewed from a distance. The extreme thinness of Saturn's rings leads to something really fascinating that happens every 15 years. As Earth's orbit takes us through the plane of Saturn's rings, something remarkable occurs. The rings seem to disappear completely. From our perspective on Earth, we're briefly looking at them edge on, and they're so thin that they become invisible to all but the most powerful telescopes. When the rings start to become visible again, they first appear as nothing more than what looks like an incredibly fine spider's thread stretching across Saturn. It takes about 6 weeks before we can start to see them properly again through telescopes. This regular vanishing act is one of the most dramatic demonstrations of just how incredibly thin these rings really are. Scientists think this extreme thinness is the result of how the rings formed and how they're maintained. The particles in the rings are constantly colliding with each other, but they're all orbiting in roughly the same plane. Any particles that orbit at different angles eventually collide with others and are forced into line. It's like a cosmic game of bumper cars where all the cars eventually end up driving in the same direction. To really appreciate how remarkable this is, imagine spreading a drop of water across a football field while keeping it just a few molecules thick. That's essentially what nature has done with Saturn's rings, except on a scale that's millions of times larger. It's as if someone took a cosmic sheet of ice and stretched it out to astronomical proportions, while somehow keeping it incredibly thin. The physics that keeps these rings so thin while stretching them out so wide is the same physics that built our solar system. It's all about gravity, motion, and the fundamental forces that shape our universe. Saturn's rings are like a miniature version of the disk of material that formed our solar system, giving us a window into how planets form and evolve. So the next time you see a picture of Saturn, remember that those beautiful rings are even more remarkable than they appear. They're not just pretty bands circling the planet. They're an impossibly thin collection of cosmic ice and rock, stretched out across a distance greater than the width of 30 Earths, yet thinner than the height of Mount Everest. They're a testament to the fact that in space, nature can create structures more delicate and precise than anything we humans could ever build. You probably think rings around planets are pretty special. After all, Saturn's rings are one of the most beautiful sights in our solar system, and you might know that Jupiter, Uranus, and Neptune have rings too. But here's something that will blow your mind. Even some asteroids have rings. And that's not all. Some asteroids even have their own moons. Let's talk about an asteroid called Chariklo. This space rock orbits the Sun somewhere between Saturn and Uranus, and it's part of a group called Centaur asteroids. These asteroids are known for their unstable orbits that cross paths with the giant planets. But what makes Chariklo really special is that it's the smallest object we've ever found that has its own ring system. Now, Chariklo itself is about 250 kilometers wide. That's tiny compared to planets, but still pretty big for an asteroid. Around this relatively small body, scientists discovered something amazing. 2 distinct rings. The inner ring is between 2 and 4 kilometers wide, and the outer ring is between 6 and 7 kilometers wide. Between them is a gap of about 9 kilometers. These rings orbit about 400 kilometers from Chariklo's center. To put that in perspective, that's about 1,000th of the distance between Earth and the Moon. It's like having a miniature version of Saturn's rings wrapped around an asteroid. The discovery of these rings was completely unexpected. Scientists found them on June 3, 2013, during what's called a stellar occultation. That's when an object passes in front of a star, briefly blocking its light. They were watching Chariklo pass in front of a distant star when they noticed the star's light dimming in a way that could only be explained by rings. The discovery was so surprising that scientists waited until March 26, 2014 to announce it, just to make absolutely sure they were right. But rings aren't the only surprising features asteroids can have. Let's talk about an asteroid called Ida and its tiny moon, Dactyl. Back in 1993, NASA's Galileo spacecraft was on its way to Jupiter when it flew past asteroid Ida. The cameras on Galileo captured something extraordinary: a small moon orbiting the asteroid. This was the first time anyone had ever taken a picture of an asteroid's moon. Dactyl is tiny, measuring only about 1.2 by 1.4 by 1.6 kilometers. Think of it as a cosmic pebble orbiting a slightly bigger cosmic rock. What's really interesting is that both Ida and Dactyl seem to be made of the same kinds of rocks. This suggests they probably formed from the same larger object that broke apart long ago. These discoveries are completely changing how we think about asteroids. We used to think of them as simple space rocks floating alone through the solar system. Now we know they can have complex systems of their own, complete with rings and moons. It's like discovering that what we thought were empty houses actually have fully furnished rooms inside. Scientists are so interested in these features that they're using our most advanced technology to study them. The James Webb Space Telescope, the most powerful space telescope ever built, has recently been used to observe Chariklo's rings. This shows just how important these discoveries are to our understanding of how our solar system works. These findings are helping us understand how rings form in general. If an asteroid can have rings, what does that tell us about how Saturn got its rings? If asteroids can have moons, what does that tell us about how moons form throughout the solar system? Each discovery gives us new clues about the processes that shaped our cosmic neighborhood. Think about how incredible this is. These asteroids are showing us that the solar system is far more complex and interesting than we imagined. Even relatively small objects can have their own miniature systems, complete with the kinds of features we once thought were reserved for planets. This also raises some fascinating questions. How many more asteroids might have rings or moons that we haven't discovered yet? What other surprises might these space rocks have in store for us? As we build better telescopes and send more spacecraft to explore the asteroid belt, we might find that these features are more common than we think. So the next time someone shows you a picture of Saturn's rings, you can tell them something that might surprise them. You can tell them that Saturn isn't the only object out there with rings. Somewhere between Saturn and Uranus, a small asteroid called Chariklo is proudly showing off its own ring system, proving that sometimes the most surprising features in our solar system come in the smallest packages. Next time you see a shooting star, don't make a wish right away. Take a moment to look at its color. That streak of light racing across the night sky isn't just putting on a show. It's telling you exactly what it's made of, painting the story of its chemical composition in brilliant colors across the dark canvas of the night sky. What we call shooting stars aren't actually stars at all. They're tiny pieces of space debris, usually no bigger than a grain of sand, that slam into the Earth's atmosphere at incredible speeds. And when we say slam, we mean it. These little pieces of rock and ice hit our atmosphere so fast that the air in front of them can't get out of the way quickly enough. This creates intense pressure that superheats the air, which in turn heats up the space debris until it vaporizes in a brilliant flash. These meteors don't just glow white. They can shine in a whole rainbow of colors, and each color tells us something about what elements are present in that tiny piece of cosmic debris. It's like each meteor carries its own chemical fingerprint, written in light. When you see a blue-white or cyan-colored meteor, you're looking at magnesium burning up in our atmosphere. Spot a violet streak? That's calcium saying goodbye in a brilliant flash. Orange meteors are showing you the signature of sodium, while yellow-white ones are rich in iron. And those distinct red streaks, those come from nitrogen and oxygen in our own atmosphere getting excited by the meteor's passage. Some meteors even put on a multicolor light show. The brightest ones, which we call fireballs, burn long enough for us to see several different colors as they streak across the sky. This happens because different elements in the meteor burn at different temperatures, creating a sequence of colors as the meteor heats up and burns through its various components. The speed of the meteor also plays a role in what colors we see. Faster meteors tend to produce more intense colors because they generate more heat as they punch through our atmosphere. Slower meteors often appear red or orange, creating a more subtle but equally beautiful display. There's another element that adds its own special touch to this cosmic light show: nickel. When present in a meteor, nickel produces a distinctive green color. This means that some meteors can actually glow green as they burn up in our atmosphere. It's like nature's own fireworks display. But instead of artificial chemicals, these colors come from elements that were forged in the hearts of ancient stars. If you want to see these colors for yourself, one of the best times to look is during the Geminid meteor shower, which happens every year in mid-December. The Geminids are famous for producing especially colorful meteors, often appearing in yellow, orange, and sometimes even green. The greenish-blue color of many Geminid meteors comes from their high content of nickel and magnesium. Here's something that might surprise you. When you see a bright fireball streak across the sky, most of the light you're seeing, about 95% of it, isn't actually coming from the meteor itself. Instead, it's coming from the air around it. As the meteor plows through our atmosphere at hypersonic speeds, it excites the gas particles in the air, causing them to glow. Only about 5% of the light actually comes from the vaporizing meteor. Scientists can learn a lot about these space rocks by studying their colors. By analyzing the spectrum of light produced by meteors, they can identify what elements were present in the original space debris. Common elements they find include iron, magnesium, and sodium. Sometimes silicon is harder to detect because it stays bound up in compounds like silicon dioxide, refusing to break apart completely even in the extreme heat of atmospheric entry. This colorful display isn't just beautiful. It's also helping us understand what's out there in space. By studying the colors of meteors, scientists can learn about the composition of asteroids and comets in our solar system. Each colored streak across the night sky is like a message from space, telling us about the chemistry of distant objects we might never be able to visit directly. So the next time you're out watching for shooting stars, pay attention to their colors. That green streak might be showing you nickel from an ancient asteroid. That violet flash could be calcium that was once part of a comet's core. Every color you see is a clue about the chemical makeup of our solar system, delivered right to us in a brilliant flash of light. Ever wonder what would really happen if your spacesuit sprung a leak? Hollywood loves to show astronauts exploding or freezing instantly in the vacuum of space. But the reality is both less dramatic and more fascinating than what you see in movies like Total Recall. Contrary to what science fiction tells us, you would not die instantly. In fact, you could survive for longer than you might think. Let's talk about what would actually happen if you found yourself exposed to the vacuum of space. The first thing you need to know is that you would have time to think and act. Not much time, mind you, but enough to potentially save yourself. You would have about 10 to 15 seconds of useful consciousness. That might not sound like much, but it is enough time to make life-saving decisions. During those precious seconds, several things would start happening to your body, and none of them are pleasant. The most immediate effect would be the rapid expansion of gases in your body. Every pocket of air, from your lungs to your digestive system, would start to expand. This is because there is no external pressure in space to counteract the pressure inside your body. It is similar to what happens when you ascend too quickly while scuba diving, but much more extreme. Your blood would not actually boil, despite what many people believe. While the lack of pressure in space does lower the boiling point of liquids, your blood vessels are strong enough to maintain pressure. However, any exposed liquids, like the saliva on your tongue or the moisture on your eyes, would begin to boil at body temperature. This process would feel strange, but it would not be immediately fatal. As these changes occur, your body would begin to swell. This swelling would be noticeable but not extreme. You would not explode like an overinflated balloon. Your skin and other tissues are remarkably elastic and can handle quite a bit of expansion. Think of it more like moderate bloating rather than the dramatic bursting seen in movies. The temperature changes might surprise you. While space itself is incredibly cold, you would not freeze solid in seconds. In fact, the biggest temperature-related problem would be overheating. Without air to conduct heat away from your body, the only way to lose heat would be through radiation, which is a very slow process. The moisture boiling off your body would provide some cooling, but heat would initially be trapped in your tissues. After those first 10 to 15 seconds, you would lose consciousness. This would happen because of the lack of oxygen reaching your brain, combined with the effects of the vacuum on your body. The good news, if you can call it that, is that this unconsciousness would be relatively painless. The bad news is that the clock would be ticking for rescue. You would have about 2 minutes before the damage became fatal. During this time, your body would continue experiencing the effects of vacuum exposure. Your lungs would be damaged from the rapid pressure change. Your eardrums might rupture. Gases trapped in your body would continue expanding, causing tissue damage. But here is the remarkable thing. If you were rescued within those 2 minutes, you could potentially survive. We know this because of actual accidents that have occurred during space research and testing. In 1965, a technician was exposed to near vacuum conditions when his spacesuit leaked in a test chamber. He remained conscious for about 14 seconds, which matches what scientists predicted. After he was repressurized, he recovered completely and only remembered that his saliva had begun boiling on his tongue. The lack of oxygen, called anoxia, would ultimately be what kills you, not the more dramatic effects people often imagine. Your body can actually withstand the vacuum of space better than you might expect. The real enemy is time. Every second without oxygen brings you closer to the point of no return. Your survival chances would depend greatly on how quickly you could be rescued and repressurized. If you were inside a space station when your suit leaked and crew members could get you to an airlock quickly, you might survive with relatively minor injuries. If you were on a spacewalk far from an airlock when your suit failed, your chances would be much lower. The stress of the situation would make everything worse. Panic would cause you to use oxygen faster and potentially make poor decisions during those crucial first seconds. This is why astronauts spend so much time training for emergencies. They need to be able to act calmly and quickly when every second counts. The damage to your body would not be evenly distributed. Your lungs would be particularly vulnerable because of their delicate structure. The rapid pressure change could rupture air sacs in your lungs and cause bleeding. Your sinuses and ear canals would also be at risk of injury from expanding gases. However, your blood vessels and major organs would be relatively protected by your body's natural pressure containment systems. So while space exposure would certainly be dangerous and potentially fatal, it is not the instant death sentence that movies would have you believe. You would have time to react. Your body would be more resilient than you might expect, and with quick rescue and proper medical treatment, you could survive what seems like an unsurvivable situation. The next time you watch a movie showing someone instantly freezing or exploding in space, you can smile knowing that the reality, while still dangerous, gives us a much better chance of survival than Hollywood suggests. It is a reminder that while space is incredibly hostile to human life, our bodies are remarkably resilient, even in the most extreme conditions imaginable. Ever looked up at the moon and thought it looks a bit distant? Well, you might be right, because our cosmic companion is actually waving goodbye. Little by little, year after year, the moon is slowly backing away from Earth. Not quickly enough that you would notice, but steadily enough that scientists can measure it with impressive precision. let's talk about why this cosmic dance is happening. It all starts with gravity, that invisible force that keeps everything from floating away. The moon's gravity does more than just create our tides. It actually squeezes and stretches the entire Earth like a rubber ball, making our planet slightly egg-shaped rather than perfectly round. Think of it as Earth wearing a gravitational corset, with the moon doing the lacing. This gravitational effect is most obvious in our oceans. The moon's pull causes the water on Earth to pile up, creating what scientists call a tidal bulge. Imagine someone grabbing a water balloon and pulling on both ends. That is basically what the moon does to Earth's oceans, creating two bulges, one pointing toward the moon and another on the opposite side of the planet. Earth spins much faster than the moon orbits. Our planet completes a full rotation in 24 hours, while the moon takes about 27 days to orbit once around Earth. Because of this difference in speed, something fascinating happens. The tidal bulge actually moves ahead of the moon's position. Picture yourself stirring a cup of coffee. The liquid never quite keeps up with your spoon, does it? It always lags a bit behind. Well, Earth's tidal bulge does the opposite. It runs ahead of the moon like an eager puppy pulling on its leash. This might not seem important, but it creates a gravitational tug-of-war that changes everything. The bulge that moves ahead of the moon has its own gravitational pull. Like a cosmic game of catch, it tugs on the moon, trying to speed it up. The moon, in turn, pulls back on the bulge, trying to slow it down. This gravitational back and forth has two major effects. First, it gradually slows down Earth's rotation, making our days very slightly longer. Second, and this is the wild part, it gives the moon a gravitational boost, helping it spiral outward away from Earth. Think of it like a cosmic slingshot. Each time the moon's gravity pulls on Earth's tidal bulge, and the bulge pulls back, a tiny bit of Earth's rotational energy gets transferred to the moon. This energy transfer acts like a gentle push, nudging the moon into a slightly higher orbit. The result? Every year, the moon moves about 3.8 centimeters farther away from us. That might not sound like much. After all, 3.8 centimeters is about the length of your thumb. But over millions of years, those tiny movements add up. We know the moon was much closer to Earth in the distant past. When dinosaurs roamed the Earth, the moon would have looked noticeably larger in the sky. Go back even further, to the early days of our planet, and the moon was so close it would have filled much more of our sky. Scientists can actually track this lunar retreat with remarkable precision using lasers. During the Apollo missions, astronauts left special reflectors on the moon's surface. By bouncing laser beams off these reflectors and measuring how long the light takes to return to Earth, we can track exactly how quickly the moon is moving away from us. But do not worry about the moon abandoning us completely. The gravitational dance between Earth and moon is a delicate balance, and while the moon is indeed moving away, it will never escape entirely. The force of Earth's gravity ensures that our cosmic partner will stick around, even if it keeps trying to maintain a more distant relationship. This whole process also has another interesting effect. Remember how the moon's gravity creates tides? Well, as the moon moves farther away, its gravitational influence on Earth gradually weakens. This means that millions of years in the future, ocean tides will be slightly less dramatic than they are today. The effect is tiny on human timescales, but over millions of years, it adds up to noticeable changes. The moon's retreat also affects Earth's rotation. As the moon moves away, it takes some of Earth's rotational energy with it. This very gradually slows down our planet's spin. As a result, Earth's days are getting longer, but do not expect to notice extra time in your day. The change is incredibly small, adding up to only about 2 milliseconds per century. This cosmic waltz between Earth and Moon tells us something profound about the nature of our solar system. Nothing in space stays exactly the same forever. Even something as seemingly permanent as the Moon's position in our sky is actually in constant flux. The universe is dynamic, ever-changing, with every object locked in an intricate gravitational dance with its neighbors. So the next time you look up at the Moon, remember that you are watching a farewell in ultra-slow motion. Our faithful satellite is indeed leaving us, one thumb length at a time, in a gravitational ballet that has been going on for billions of years and will continue for billions more. Speaking of the Moon, that familiar silvery white disk in our night sky is hiding a secret. While we see it as a monochrome world of grays and whites, the Moon is actually a subtle palette of colors invisible to our naked eyes. Think of it like a painting that reveals hidden details under different types of light. What appears as a simple black and white photograph is actually a canvas rich with blues, yellows, and even hints of red. Let's take a virtual tour across the lunar surface and explore these hidden hues. One of the most famous regions of the Moon is Mare Tranquillitatis, better known as the Sea of Tranquility. While it might look gray to our eyes, it actually has a subtle but distinct bluish tint. This is not just a trick of the light. The blue color comes from vast floods of ancient lava, rich in titanium, that cooled and solidified billions of years ago. Travel across the lunar surface to Palus Somni, the Marsh of Sleep, and you will find an area that looks distinctly sandy in color. These subtle variations in tone have been noted by astronomers for centuries, peering through their telescopes and carefully documenting these faint but unmistakable differences in color. Each of these hues tells us something about the Moon's violent volcanic past. But the real star of this lunar color show is the Aristarchus Plateau. This enormous highland region rises above the vast plains of Oceanus Procellarum, the ocean of storms, and it stands out for its striking yellowish color. Astronomers often describe it as mustard-colored, making it one of the most conspicuous colored regions on the entire lunar surface. This distinctive color comes from a thick blanket of volcanic ash, or what scientists call pyroclastic material, that covers the plateau. This volcanic ash tells an explosive story. Billions of years ago, the Moon was a much more active world, with massive volcanic eruptions that would have been visible from Earth. These eruptions sprayed tiny droplets of molten rock that cooled into dark glass beads, creating layers up to 100 feet thick in some places. Today, these ancient deposits give the Aristarchus Plateau its distinctive yellow hue. Modern technology has revolutionized how we see these lunar colors. The Lunar Reconnaissance Orbiter, a sophisticated spacecraft orbiting the Moon, has captured incredible images that reveal these subtle color variations in stunning detail. When scientists process these images, enhancing the natural colors, they can create maps of the Moon that look more like abstract art than the familiar gray world we know. These colors are not just beautiful, they are also incredibly valuable to scientists because they tell us about the Moon's composition and history. Different minerals reflect light in different ways, creating distinct color signatures. Blues often indicate areas rich in titanium, while reds might point to iron-rich deposits or glassy materials created by ancient volcanic eruptions. Think of it like reading a book written in colored ink, where each color tells a different part of the story. The blues of Mare Tranquillitatis reveal ancient lava flows rich in certain minerals. The mustard yellow of the Aristarchus Plateau speaks of explosive volcanic eruptions that sprayed the surface with molten glass. Even the subtle reddish hues found in some crater regions tell us about violent impacts that melted and transformed the lunar rocks. When we enhance these colors in photographs, we are not creating something artificial. Instead, we are revealing something that has always been there, just beyond the limits of our human vision. It is similar to how infrared cameras can show us heat that we cannot see, or how radio telescopes can detect invisible waves coming from space. The colors are real. We just need special tools to see them. The fact that these colors have been documented for centuries adds another layer to the story. Long before we had sophisticated cameras and spacecraft, astronomers peering through telescopes noted these subtle variations in color. They carefully mapped and described these different hues, building up a picture of a moon that was far more varied and interesting than most people imagined. Today, these color variations help scientists understand how the moon formed and evolved. By studying the distribution of different colored regions, researchers can track ancient lava flows, identify deposits left by volcanic eruptions, and even find areas where impacts have exposed deeper layers of lunar material. Each color is a clue that helps piece together the moon's 4.5 billion-year history. This hidden palette of lunar colors reminds us that even familiar objects can hold surprising secrets. The moon might look like a simple gray disk to our eyes, but it is actually a complex world painted in subtle shades of blue, yellow, and red. These colors tell the story of a dynamic world shaped by volcanic eruptions, massive impacts, and billions of years of cosmic history. So the next time you look up at the full moon, remember that you are seeing only part of its true face. Behind that silvery glow lies a colorful world, its surface painted by ancient volcanoes and impacts in hues that tell the story of our nearest celestial neighbor's violent and fascinating past. Ever played musical chairs with planets? It turns out our solar system might have. Scientists now believe that Uranus and Neptune, our system's ice giant planets, might have actually switched places early in their history. Imagine discovering that your two neighbors had secretly swapped houses billions of years ago. That is basically what might have happened with these distant worlds. The story starts with something scientists call the Nice model, named after the city in France where it was developed in 2005. This model tells us that our solar system was not always arranged the way we see it today. Instead, all the giant planets from Jupiter to Neptune started out much closer to the Sun, huddled together like cosmic neighbors in a surprisingly compact neighborhood. In those early days, Jupiter sat at about 5.5 times Earth's distance from the Sun. Saturn was a bit further out at about 8.5 times Earth's distance. Uranus and Neptune were cozied up relatively close too, between 11 and 17 times Earth's distance from the Sun. That might sound far, but considering where they are now, it was practically next door. But this arrangement was not meant to last. As the early solar system evolved, these giant planets started to move. They were pushed around by their interactions with a massive disk of smaller objects, sort of like cosmic debris left over from the solar system's formation. Think of it like a giant game of pool, with planets as the balls and countless smaller objects affecting their movements. This is where things get really interesting. Computer simulations of this period show something remarkable. As Uranus and Neptune were being pushed outward by all this gravitational interaction, they did not just move away from the Sun. They actually switched places. Uranus, which we now think of as the seventh planet, might have originally been the eighth and final planet in our solar system. The swap probably happened about 650 million years into our solar system's history. That sounds like a long time. But remember, our solar system is about 4.5 billion years old. This planetary switcheroo happened during its relatively young days, when things were still settling into place. What caused this cosmic chair swap? It all comes down to gravity and something scientists call angular momentum. As these planets interacted with the disk of smaller objects in the outer solar system, called the Proto-Kuiper belt, they exchanged energy and momentum. It is like a cosmic game of pinball, with the planets being knocked around by countless smaller objects. Jupiter, the biggest planet in our solar system, played a crucial role in all of this. Its enormous gravitational pull was like a cosmic bouncer, throwing many of these smaller objects completely out of the solar system. As it did so, it moved slightly inward, while the other planets were pushed outward. This process helped drive Uranus and Neptune's migration and eventual position swap. This planetary migration was not a quick process. It took hundreds of millions of years, as the gas and dust from the original solar system slowly dissipated. During this time, the gravitational dance between the planets and smaller objects gradually reshaped our solar system into what we see today. The idea that Uranus and Neptune switched places might sound far-fetched, but it actually helps explain some mysterious things about our solar system. One of the biggest puzzles about Uranus is that its entire system is tilted on its side, like a top that has been knocked over. The gravitational interactions that caused it to swap places with Neptune might also explain this unusual tilt. The NICE model, which predicts this planetary swap, also helps explain other features of our solar system that have long puzzled scientists. It helps us understand the late heavy bombardment, a period when the inner solar system was pelted with asteroids and comets. It also explains the current structure of the Kuiper belt, that region of icy objects beyond Neptune where Pluto lives. Both Uranus and Neptune are what we call ice giants, made primarily of water, ammonia, and methane ice, unlike the gas giants Jupiter and Saturn. Despite being relatively similar in composition, their different positions in the solar system today affect how they behave and appear. The fact that they might have switched places adds another layer to their already fascinating story. This grand reorganization of our solar system shows us that even planets are not content to stay in one place forever. Our cosmic neighborhood has a history of change and movement that continues to influence what we see today. The next time you look at a map of the solar system, remember that what you are seeing is just a snapshot in time. In the past, things might have been quite different, with Uranus and Neptune playing a cosmic game of musical chairs that helped shape our solar system into what it is today. So while we cannot go back in time to witness this planetary swap meet, the evidence suggests that our solar system's current arrangement might not be its original one. It is a reminder that even in space, change is the only constant, even if that change happens over hundreds of millions of years. We have had plenty of visitors to our solar system before, from comets to asteroids, but in 2017 we spotted something completely different. For the first time in human history, we detected an object that came from another star system entirely. This interstellar visitor, named Oumuamua, which means scout in Hawaiian, turned out to be one of the strangest objects astronomers had ever seen. The discovery was made by astronomer Robert Weryk, who was working at the Pan-STARRS telescope in Hawaii. At first glance, it looked like just another space rock. But as astronomers tracked its path through our solar system, they realized this was no ordinary visitor. The object was moving too fast, and its trajectory was unlike anything they had seen before. It was not bound by the sun's gravity like everything else in our solar system. The thing was just passing through. But that was just the beginning of the strangeness. As scientists scrambled to study Oumuamua during its brief visit, they found that it had a shape unlike any asteroid or comet we had ever seen. Picture a massive cigar floating through space, or maybe a cosmic pencil. The object was incredibly long compared to its width, potentially up to 10 times longer than it was wide. Estimates suggest it could be anywhere from 300 to 3,000 feet long, but relatively thin, like a giant space cucumber. The peculiar shape was not the only thing that puzzled scientists. As Oumuamua sped away from our sun, it seemed to accelerate slightly. This is not completely unheard of. Comets often speed up as they near the sun because their ice turns to gas and creates a kind of natural rocket effect. But Oumuamua showed no signs of being a comet. There was no visible tail, no cloud of gas and dust around it, nothing to explain this mysterious acceleration. The object's color added another layer of intrigue. Oumuamua had a reddish tint similar to some objects found in the outer solar system. This coloring suggested it had been exposed to cosmic rays for millions of years as it traveled through interstellar space. It was like a cosmic wanderer, weathered by its long journey through the void. Scientists had to work fast to gather data. Oumuamua was already on its way out of our solar system when we spotted it, about 33 million kilometers from Earth. That might sound like a lot, but in astronomical terms, it was practically next door, and it was moving fast, really fast, at about 70,000 miles per hour. This gave astronomers only a brief window to study our mysterious visitor before it disappeared into the depths of space. The limited observation time meant that many questions about Oumuamua remain unanswered. We still do not know exactly what it is made of, where it came from, or how it got its unusual shape. This uncertainty has led to all sorts of speculation. Some scientists suggested it might be a piece of a destroyed planet. Others thought it could be an icy body ejected from another star system. A few researchers even proposed more exotic explanations, though most astronomers stick to natural explanations. Just 2 years after Oumuamua's visitor, astronomers spotted another interstellar visitor. This one, named Borisov after its discoverer, was much more conventional looking. It was clearly a comet, with the classic fuzzy appearance and tail that we expect from comets. This second discovery suggested something fascinating. Interstellar visitors might be quite common. We just had not been able to spot them before. Our solar system might regularly receive visitors from other star systems. Each one is like a message in a bottle, carrying information about distant parts of our galaxy. These objects have traveled for millions of years through the void of space, passing countless stars before chance brought them into our neighborhood. The discovery of Oumuamua and Borisov has changed how we think about our solar system's relationship with the rest of the galaxy. We now know that the space between stars is not just empty void. It is more like an ocean, with objects drifting between star systems, carrying material from one cosmic shore to another. Our solar system is not isolated. It is part of a larger cosmic ecosystem where matter can and does move between the stars. These interstellar visitors also raise intriguing possibilities. If objects can travel between star systems, could they carry the building blocks of life? Could impacts from interstellar objects have played a role in Earth's history? And how many more of these visitors might we find now that we know to look for them? As Oumuamua continues its journey through space, now well beyond our ability to observe it, it leaves behind a legacy of questions and possibilities. It reminds us that the universe is full of surprises and that sometimes the most fascinating discoveries are the ones we cannot fully explain. Our first known interstellar visitor might be gone, but it has opened our eyes to a new aspect of our cosmic neighborhood, where wandering objects carry secrets between the stars.